Dear friends, welcome to DB Infotech YouTube channel. This is my tutorial 3 in Crystal Explorer software. In this video, I'm going to teach you how to create Hirshfeld surfaces using Crystal Explorer software. So this is the model system saccharine molecule I'm going to use to teach how to make this kind of surfaces. Here what they did, they used saccharine zip file they downloaded from the website and made this kind of surfaces. Actually, in the saccharine molecule, the Hirshfeld surface mapped with this pro-molecule density and electron density and deformation density and electrostatic potential, finally orbital density. Actually, they mapped Hirshfeld charges with these properties. So I'm going to teach you how to map Hirshfeld charges or surfaces with these properties. First, we will download saccharine molecule zip file from the website. So if you have your own crystal structure also, you can do this kind of analysis. You can use it for your research papers. It's very useful software. So now we will go to download our this saccharine molecule. Go to this ccdc.com.ac.uk structures. So here you can see CCDC number, CSD number, CSD reference code, something is there. So if you know this any one kind of course, you can just put here and you can search and you will get your crystal structure. So actually, so this is the paper. Actually, I showed this paper to last video, the tutorial 1. So this is the paper, Journal of Applied Crystallography. So here if you go to down, so they have mentioned the CSD code. Yes, CSD code SACHRN02. This is the code of this saccharine crystal zip file. So we can use this code to get from the CCDC website. So just you can copy this. So just see this is the one. Just you can copy, paste it here and search. So you will get your crystal structure here. Here, see, this is the molecule. This is the 2D structure. This is the 3D structure. So here you can see, click download. You click this download and you see different kind of things. So download current entry. So then it will ask something, name and email and institution. Just put whatever you want. That's no problem. And just you can click it down. Yeah, this is the zip file of this saccharine molecule. So just you can copy this, keep our folder. So this is the zip file of saccharine. So we can see this zip file using Vesta program. Just I want to see the structure, how it looks. So just you can open your Vesta. So this is the Vesta program. If you did not install this program to your computer, just go to Google and type Vesta. You will get this software. This is free only. So you can use for your academic purpose. So I want to see that the crystal structure, how it looks. So this is the saccharine molecule crystal structure. So we can use this Vesta to see the crystal structure of this saccharine. So just I can drag this molecule to Vesta program. So this is the crystal structure of saccharine molecule. So the main uses of this crystal explorer is to see the hydrogen bonding or close contact of this kind of molecules. So you can see here there is the close contact or hydrogen bonding in between these two molecules. You can see this NH interact with this one of O molecule. So likewise this another molecule NH interact with this O molecule. So this kind of interactions we can analyze using this crystal explorer software. This is the main use. You should understand this. So now I can close this Vesta program. No need. Just want to see this structure. We have seen that one. That's enough. Just I can close it. So this is the saccharine molecule zip file. We are going to use this one into the Crystal Explorer. Now we can make Hirshfeld surfaces mapping with different properties like electron density, promolecular density, and electrostatic potential and deformation density. This kind of properties we are going to map with Hirshfeld surfaces. So for that, first we are going to open our Crystal Explorer software. So this is our Crystal Explorer software. So go to this file option, go to your folder. So this is our saccharine molecule crystal structure. Just you can highlight, here you can open. So our zip file is open now. So you can keep good orientation. So this is the, I think, good orientation of this saccharine molecule. So one more thing you should understand, only zip file containing this kind of intermolecular interaction can be used to visualize this kind of properties. So now we can make one by one this Hirshfeld charges mapping with properties like electron density, other electrostatic potential kind of things. So what we have to do, just we have to double click any one of the atom to select the whole molecule. Now our molecule is selected. So now what you have to do, go to this generate surface, click this generate surface. You can see Hirshfeld, here none, here standard I, something is there. So you can keep this Hirshfeld charges default, here property. So if you want, you can keep any mapping with this kind of properties. So we are going to map this pro-molecule density with Hirshfeld. So just put that pro-molecule density. You can click this is the very low high standard. This is a good. So now you can click OK. After of minutes or within 1 minute, you will get your surface. You can see calculation is running. So one boy is running like that showing. So that means our calculation is now running. So our surface created Hirshfeld surface mapped with pro-molecule density. So this is the things. From here you can get some different properties. If you click this none, so you will get just pro-molecule density. So if you want to see that transparent surface of this pro-molecule density, just you can click this enable surface transparency. Now you can see your pro-molecule density with the transparent saccharine molecule. Now we can make different surfaces. So here first we given none. So now we can click the DI. So now we will get that DI surface. DI means what? So just to go to that paper. So you can see here di means distance from highest field to surface nearest atom I internal to the surface. So this is the di. Then d norm, this kind of things we can get from this calculation. So that so our di surfaces, this is the di surfaces. So our calculated di surfaces, so this one. So this is same surface, the di surface. Then we want to de surface, so this is the de surface. Then we can make d norm surface. This is the d norm surface. So what is d norm means? D norm is normalized sum of dE and dI. So this is the formula. So this is the d norm surface. So we can also check with this paper. So this is the d norm surface. You can see this, the same only. So next we can make curvedness, shape index, fragment path. So this we can make up to this pro-molecule density we can make. So you will see one by one. D norm we finished. Shape index. So this is the shape index. Then curvedness. So this is the curvedness. So you can see it. So see this is the curvedness. The space index also we made last image. Then a fragment path. So go here, you can check fragment path. So we can disable this. We can see our fragment path. See, this is our fragment path. So if you want to save this image, just to go to snipping tool or screenshot. So just you can select that image. So now you can save. So this is the method you should save your image from this Crystal Explorer software. So we have made a different kind of things with this one. So this is the pro-molecule density. So we are mapping with this property with that Hirshfeld charges of surface. So this is the things. Now we can see another things like electron density, deformation density, electrostatic potential, and orbital density like Ohm. So we can see one by one this one. So for that first we can remove this one. So we can delete it. That's all, we removed that one. So now again we have to select all the molecule by clicking any one of the atom. Then go to surface, creator, generation. Here you can mention as field. Then you can check electron density. So this is the electron density. Here you can mention standard. Here generate new wave function. So this is the important things. We need to generate wave function for this kind of calculations. So you can see also detailed things. So electron density calculated from wave function in the previous energy calculations. So we have mentioned the standard. So now we can click OK. So here it will ask, so what are the method and basis set to choose to run this calculation. So we need to choose B3IP 631G star. So I will use, if you use some other best, it will take more time. So for that, this also will take more time. Just I will use. So we have to wait some time, then only the calculation will complete. So just I can select this one, then click OK. So now see our electron density calculation is running. So we have to wait to 5 to 10 minutes to complete this calculation because we are using B3LP and 631G star set for these calculations to generate wave function. Yes, our calculation is now completed. So this is the Hirshfeld surfaces mapped with electron density. So if you want to see the transparency, just click it. You will see the transparent molecule on this surface. So That's all. So if you want to save, already I told you, go to the screenshot or snipping tool, you can save. So just go to new, just you can select it and go to file, save as images, capture. This the name. If you want, you can change the name. That's all. Like that you can change. So now we can do so different another things. So now we have gained the electron density. So if you go to that paper, so then they did the deformation density and electrostatic potential and the orbital density. So we have to create three more things. So for that, what you have to do, just again you can remove this. So now click it and delete that these surfaces. Now we can make new one. So again, just you can double click, then go to surface. Again, you can default you can keep as fill. Then from the electron density, just you can make deformation density. So standard you can keep high. So now we can generate new wave functions. Then you have to click OK. Then this will ask that program method basis set. You can keep this default. No problem. Just you can click OK. Already we have created wave functions. So do you want to continue with wave function calculation? No, this will replace existing wave functions. So if you want to click, you can, yes, it will create new wave function. Click yes. Now the calculation is running. So we have to wait some time until the calculation completes. Yes, now our calculation is completed. So the deformation density created. So this is the deformation density of this saccharine molecule. If you want to see transparency, just click it and see the transparency of this system. So that's all. So if you want to save, just you can screenshot it using snipping tool or a screenshot, and you can save as a image. So that's all. Now we can make one more property called that electrostatic potential, and one more thing is the orbital density. So now we can remove this surface. So now we can make electrostatic potential. So again you can select, double click any one of the atom, then go to generate surface. Here you can change into electrostatic potential. You can create new wave function and click OK. So it will show this one. So we can keep it default Tonto and B3LYP 631 G star. So now click open. So again it will ask wave function. This already exists. Do you want to continue with wave function calculation? So if you press no, I think this will use old wave function. So we will try with clicking no. I think not working. So again we can go to generate surface. Again you can select this electrostatic potential. So in the standard I, then click OK. Calculation is running. Our new wave function file will be created for this electrostatic potential calculations. So we have to wait some time. I think our calculation is completed. So electrostatic potential surface created. So again, if you want to see transparency, just click it OK. Enable this one. You will see the molecule inside the surface. So that's all. Now you can screenshot it, this one, using snipping or other screenshot method based on your computer. Save as a image. So we cannot export this image from this software. There is no option available till now. So next we are going to make orbital density. So again, remove this one. Again, double click, select all the atom, go to surface. Here you can keep Hirshfeld. So here, property, orbital. So here you can click HOMO or LUMO. Earlier video also I clearly explained what is HOMO -1, -2 and LUMO +1, +2, +3 like that. Okay, now we can generate only HOMO of this molecule. So keep it generate new wave function and click it OK. So you can keep default these things. Then you can again click OK. Now then only the calculation will run. So again you can click yes. So now our calculation is running. So you have to wait some time. Yes, our orbital calculation completed. So this is the Hirshfeld surface mapped with that orbital. So this is actually HOMO. So we have created different kind of things like pro-molecular density, electron density, and electrostatic potential, deformation density, and orbital density. So this is the method. So we have to do in order to make this surfaces. So you should have your crystal structure, then you can import it and do this kind of calculation, get your surfaces mapped with Hirshfeld charges. So that's all this tutorial. So next video I will tell you different kind of things like intermolecular interaction kind of things. So thank you for watching my video. If you like my content, please subscribe, comment and share to your friends. Thank you for watching. Enjoy.